In this video, we're going to go over AP Calculus AB 2018 exam free response question number 5. So we're given a simple function here, e to the x times cosine of x, and we're asked for the average rate of change of that function on this interval. Well, the average rate of change is just another word for the slope of the line connecting those two endpoints, or the slope of the secant line connecting those two endpoints. So that's easy enough. Just find the slope. So that's going to be, for part A, f of pi minus f of 0 over pi minus 0. Now f of pi, I could leave this just as e to the pi cosine of pi minus e to the 0 cosine of 0 over pi, and that would be fine. I don't need to simplify any past that. But I, of course, could and replace the cosine of pi with a -1, because cosine of pi is -1, and then cosine of 0 is 1. So this would be minus 1 because e to the 0 is 1 over pi. But I would recommend leaving it here. Don't need to simplify past that, so all you can do is lose a point by making a mistake. What is the slope of the line tangent to the graph of f at x equals 3 pi over 2? Well, that's just another way of saying what is f prime of 3 pi over 2. So take the derivative, plug in 3 pi over 2. Now for f prime of x, we need quotient rule here because we have e to the x times cosine of x. So take the derivative of one of the factors, leave the other one, add where you switch which one you've taken the derivative of and which one you've left. I'm going to take the derivative of e to the x first because it's just e to the x, leave the cosine of x. Now plus, leave the e to the x and take the derivative of cosine of x, and that's negative sine of x. And now I just need to plug in 3 pi over 2. And just like in part A, yes, I should know my unit circle. I should be able to simplify this, but for this particular part, I don't need to. I'm just going to leave it as e to the 3 pi over 2 times cosine of 3 pi over 2 plus e to the 3 pi over 2 times negative sine of 3 pi over 2. And I would just leave it as that. Hopefully your handwriting is better than mine with this stylus, but that's where I would leave it because I don't need to know anything about what that number is. So I'd just leave it there. Okay. I'm going to clean those up. I don't need any of that for the next part, so pause and write any of that down if you need to. Part C, we're finding the absolute minimum. Now we know that the absolute minimum can occur at an endpoint, so in this case 0 or 2 pi, or a critical number. So we need to know where that derivative is undefined. So we took the derivative a moment ago, and it was e to the x cosine of x minus e to the x sine of x. Instead of making that, keeping the negative with the sine of x, I just pulled it out there. And I need to know where this is 0 or undefined. Neither e to the x, nor cosine of x, nor sine of x are ever undefined. They all have a domain of all real numbers. So no critical numbers where the derivative is undefined here, which is nice. Set it equal to 0, and we can factor out an e to the x. And then we're left with cosine of x minus sine of x. Now, we set each of those factors equal to 0, and cosine of x is never, e to the x is never 0. So it's not that I'm dividing that to the other side and making it go away. I'm setting that equal to 0, and I'm saying that never happens. Then I set the other one equal to 0. 0 equals cosine of x minus sine of x. Now in part A and B, I said, you should know those unit circle values, but it doesn't matter. Here it does matter because in order for this equation to equal 0, cosine of x and sine of x must equal the same thing. Now where does that happen? Well, that happens when x is pi over 4 in the first quadrant. Both cosine and sine are root 2 over 2, or 1 over root 2 if you prefer. But then it happens again in the third quadrant when both cosine and sine are negative root 2 over 2. It doesn't happen in quadrant 2 or 4 because in those instances one of these values is positive and one of these values is negative, so they won't cancel each other out. So the values I have to consider here are 0, pi over 4, 3 or 5 pi over 4 in quadrant 3, and 2 pi. And we just need to know what's the value of each of these things. And if I plug that into the derivative, and you can check my work, I think, if we need to, but I believe this is going to be 1. This is going to be e to the pi over 4 times root 2 over 2. And then e to the 5 pi over 4 times negative root 2 over 2. And then e to the 2 pi times 1. And remember, when I'm plugging those values in, I'm plugging those into the original function, because I'm saying these are the possible x values where the original function has an absolute minimum. So we just look for which one of these potential candidates at an endpoint or a critical number is the smallest. And this is one where people often are scared because they don't have a calculator, but notice I don't need a calculator to know which one of these is the smallest. Only one of them is negative, so that one is the smallest. And it does ask me to justify, so I'm going to say the absolute minimum is, abs min is 5 pi over 4, comma, negative e to the 5 pi over 4 times root 2 over 2. And that's because the absolute minimum must occur at an endpoint, or critical number, and this is the smallest of those. We're not looking for beautiful prose here. We're just looking for short, simple, concise to say that's how I know that that's what the answer is. All right. So part C took up a lot of space there. Let's clear it out and make room for part D. So in part D, they give us a new function here, g, and they say that it's differentiable, and then the graph of g prime, the derivative of g, is shown, and we need to find the value of this limit here. Now, anytime you have limits, the first thing you always have to do is plug the number in to see what happens. We might just get lucky and plugging in the number, what we call direct substitution, actually gives us a value, and then we say, okay, this is the value. But when we do that, in this case, the limit as x approaches pi over 2 of f of x over g of x, well, I do my direct substitution. That's not an equal sign. It's telling me what happens here. Well, f of pi over 2, cosine of pi over 2 is 0. So 0 times e to the pi over 2 is just 0. And then they tell me here that g of pi over 2 is 0. So that's not just undefined with the 0 in the denominator, but it's what we call an indeterminate form. 0 over 0 or infinity over infinity are the indeterminate forms we use in AP Calculus. There are others, but those are the ones we use in AP Calculus. So that tells me I can use L'Hopital's rule, which is where we say let's reevaluate that same limit as x approaches pi over 2 of f prime of x over g prime of x. Take the derivative of the numerator and denominator separately, not using quotient rule. Now, if we look at our derivative from before of f of x, our f prime of x, that was e to the x times sine of x, or cosine of x minus sine of x. I like the factored version better. It's a little easier to work with. So f prime then of pi over 2 is going to be e to the pi over 2 times, well, cosine of pi over 2 is 0, minus sine of pi over 2, which is 1. So this is going to be negative e to the pi over 2. So that's f prime of x. Negative e to the pi over 2 over, and g prime of x, we can tell from the graph here, or g prime of pi over 2, we can tell from the graph here, is 2. And so that is my answer. They want us to justify. And so there's a couple things that we need to say here. And one is because g of x is differentiable, it is also continuous. It is also continuous. So the limit as x approaches pi over 2 of g of x equals g of pi over 2. And that's key because that was the whole thing that we did here, was we knew that this g of x was 0 here. You know, if g of x is not continuous, it's possible that you have a crazy graph where you have, you know, a filled in point, you know, some sort of piecewise function where at pi over 2 there's a filled in dot at 0, but then the other side of the function, you know, there's a hole somewhere and the function's not continuous there, and thus the limit is not the same as the function value. But because it's differentiable, it must be continuous, and this must be true. And so because g of x is differentiable, it's also continuous. And then I'm going to say, so we can use L'Hopital's rule to evaluate. So it's really this differentiable implying continuity piece, and that being required to get this 0 that they want you to justify there. Okay, so that's number 5 from 2018.